In Geometry Section 2.5, we're going to be dealing with postulates and theorems and proofs. So this is going to be the start of what a lot of people are complaining about geometry, which is our proofs. We're going to start slow and sort of ease onto it. But in order for you to actually do proofs, you have to understand how to prove certain statements true. What that means is there's two things you're going to be dealing with: postulates and theorems. The first one is a postulate. A postulate is what is called accepted truth. So it's kind of the thing that you can't really prove, but it's logical, it makes sense, and nobody's been able to prove it wrong. So that's what is called a postulate. So for example, we have, and every postulate has a number. It's different in every book. So usually we have titles. So this is postulate 2.1. And it says through any 2 points is one line. So basically if I put any 2 points anywhere, you can only draw one line through it. Now 2.2, postulate 2.2 says through 3 points not on the same line, there is one plane. So 3 non-collinear points. So if I put 3 points randomly and I don't put them in the same line, I create what is a plane. And there's a few others on page 106. Now those are going to be able to be on your flipper, but for the most part they're pretty self-explanatory. And you're going to use these to prove what you want to prove. And if that doesn't make sense now, that's okay. When we get into proofs, you'll understand why we need to know these. So go ahead and write this down, and don't forget your vocabulary. And we're going to move on to theorems. Theorems are slightly different. Instead of accepted true, these are the ones that are actually proven true. So they've gone through a whole process of factual statements, of testing, and all that sort of stuff, and these are proven true statements. For example, the midpoint theorem. When you think about midpoint, what did we learn about midpoint? Midpoint is a point that's exactly in the middle, right? And because it's in the middle, it cuts the line into what? 2 congruent parts. Now, that's exactly what the theorem is stating. It's saying if M is in the midpoint of AB, so what it's saying is there's a line, AB, okay, and M is somewhere in the middle, then what do I know? That because this is the middle, this line and this line equal each other. That's what it states. AM is equal to MB. This is called the midpoint theorem. So as you go on through the chapters now, you're going to have a whole collection of postulates and theorems, mainly theorems, on things that have been proven so that it can use it to prove other statements. Go ahead and write this down. We're going to start with an example. Okay? The first example, it says determine the number of segments that can connect the points. These questions are usually to help you understand logic a little bit more. So basically it's saying how many lines can I create to connect the dots? And to make it pretty simple, all we need to do is just start drawing lines. So here's 1, 2, 3. Okay? On this line, I'm not going to have 3 because I've already connected this one. So 4, 5. And on this line, I've already connected to these 2, so my last one is 6. So how many lines can I create from here? New lines? 6. Right? Page 107, number 2 is very similar. You do the same thing except there's more points. So you kind of have to figure out a little bit more. But it's pretty straightforward. You just connect the dots, and only new lines can be counted. The next one, we're sort of starting a proof. Now, your book talks about paragraph proofs, but we're not even going to mess with paragraph proofs. We're going to go straight into 2-column proofs. And basically, you can write in basically a 2-column proof and paragraph proof. The difference is one is in 2 columns, and the other one you write out sentences. So I'm more interested in you knowing how to create these kind of proofs. And basically, a 2-column proof has 2 columns. And the first one is statements. These are the things you're trying to prove true. And then the next one is reasons. So reasons, this column right here on your reasons, this is where you're going to use your proofs, your postulates, your theorems in order to prove this side. So this side are your statements, this side is what you're using to prove the statement. And with any proof, any proof, you always start with the given in any proof. What that means is What is the original thing, the original information they're giving you before you try to figure out what they're trying to prove. So here is my given. AC equals CB, and C is between A and B. Alright? And it wants us to prove that C is the midpoint of AB. This is my answer. They give me this information and they want me to get to here using logic. So my first is going to be my given. AC equals CB. And my reason for me saying that this is true is because this is the information they gave me. So I can put given. Again, always start with your given. But I have two givens. The second one is stating C is between A and B. This is another given. Now what they want me to prove is that C is the midpoint of AB. So basically it's telling me that there's a line AC and CB and they're equal to each other. And C is between A and B. So C is between A and B. And it's telling me that AC is equal to CB. Okay? So I do know a theorem called the midpoint theorem. And the midpoint theorem is stating that if M is between, so if a point is in the middle of a line, then those two, okay, are equal. So this one is a pretty short one. My last step, I'm going to say that C is the midpoint. And my reasoning, because of all this information that I have, is going to be midpoint theorem. So one more time. The only reason why I was able to put the midpoint theorem is because they've given me the two informations that make the midpoint theorem. And because once I combine that, I get the midpoint theorem, so I can state that C is the midpoint. So go ahead and try page 107, number 7. If you don't quite get it, we'll go over it in class. So do page 107, number 2, and then 107, number 7, and I'll see you in class.